All right. Wonderful to be with you all. Thank you so much. My name is Cliff Anderson, and as you said, I'm here with Corey Brady, Brian Broll, and Mark Schoenfield. And I believe that Brian will be running our slides. Is that right, Brian?
Yeah, sure. 1 second.
Okay. Give it a second to bring up. Do you need the link?
I got it.
You got it.
Just took me 1 moment here. All right. Okay,
all right.
Good.
Okay, fantastic. So the four of us teach a non-credit fellowship program at Vanderbilt University called Modalities of Text Analysis. And the fellowship introduces undergraduates to the basics of text mining and natural language processing. And during the semester, we explore ideas ranging from term frequency indexes to topic modeling. Our primary data set for the fellowship, as you can see here from ProQuest, is a set of roughly 3.5 million articles of British periodical literature, originally published from the late 17th century to the early 20th. And Professor Mark Schoenfield is our expert in this area. So if you want to ask him about that, the shape of the data, I'm sure he'd be glad to talk about it. But students apply for our fellowship from many different disciplines. We typically have a number of English majors and computer science students, along with undergraduates from fields ranging from history to religious studies. And the students arrive with starkly different levels of programming experience. Some come with strong backgrounds in programming languages like Python, but other students arrive never having programmed at all. And our aspiration is to make the fellowship equally accessible to everyone who takes part. So are we able to achieve that ambition in practice? Let's go to the next slide. So we want to work in this pretty complex environment called Apache Spark. And for those of you that haven't used Spark, Spark is what they call a unified analytics engine for large-scale data processing, or to put it more simply, a programming environment for analyzing big data. By distributing data across multiple nodes, Spark allows us to spread the work of processing data. And Spark handles the complexity of orchestrating tasks on the cluster, allowing users to focus on their queries. But a principal challenge of using Spark is setting up a cluster, as you could imagine. At present, we're using Amazon's Elastic MapReduce for Spark. EMR provides tools for configuring, creating, and managing clusters on demand inside of Amazon Web Services. To provide students with access to our Spark clusters, we use Elastic MapReduce Studio, EMR Studio, which provides a simplified interface to EMR. With EMR Studio, students can log directly into a workspace where they can host and maintain Jupyter notebooks. They're able to attach these notebooks to our cluster and write code in Python using PySpark to create and execute tasks on Spark. And while there are some peculiarities of using Jupyter notebooks on Spark, such as how to load programs and packages from PyPy, Amazon in general has done an excellent job in EMR Studio of creating an environment for data analytics and data analysts so that they can focus on analytical tasks rather than on software engineering tasks that is required to create and maintain a Spark cluster. As faculty, we take care of setting up Spark on EMR and loading the data set onto AWS S3. So if you got through everything I just said, you'll recognize the shape of the problem that we face. When we're working with students that have no prior coding experience, that's throwing a lot of information at them really fast. And as streamlined as it is, EMR Studio assumes a significant background in software development. You need to understand the basics of Python, how to find and import packages on PyPy, and also how to use PySpark to interface with Spark's native data structures. For undergraduates with 1 or 2 years of computer science coursework, learning the basics of PySpark is challenging, but it's doable. For students coming from majors in the humanities and social sciences, we found that the cognitive load is simply too high. So in our fellowship program, we begin by leveling the field by introducing them to NetsBlox, which we've heard a lot about. And as you know, NetsBlox builds on Snap. And we find that the palettes of color-coded blocks, as you all know well, puts non-coders at ease. And the syntax disadvantage that novice students have that have no prior coding knowledge disappears. Everyone quickly figures out how to manipulate these blocks and stack them together to create units of computation. So by moving beyond matters of syntax, NetsBlox allows us to focus on bigger questions about computing with data. Of course, students from computer science will have a stronger grasp of topics like variable assignment, control structures, events, and message passing than others. The English majors have a stronger sense, of course, about the shape of the data, grasping how patterns of language shift synchronically between journals and change diachronically over the centuries. As the fellowship program evolves, we ask students to collaborate in peer groups, bringing their different fields together to bear on matters of coding and interpretation. As we introduce students to programming in NetsBlox, we focus on the functional style of programming with data as a propedeutic to learning Spark. And as you see here, in the context of NetsBlox, this means in particular working with these three blocks. I put them in a list to make it easy to see on the screen: map, keep, and combine. As you know, the map block functions like map in other languages, applying a function to every element of a list. The keep block is more commonly known as filter in other programming environments, including Spark. And this block applies a Boolean operator to every item in the list, reporting a new list composed only of items that pass the Boolean test. The combine block takes a list and aggregates its elements into a single value, such as a string or a number. In Spark, the combine function is known as reduce. Typically, students, we find, are less familiar with map, keep, and combine than with imperative control structures for looping over lists. Exploring with them how to apply these in combination with simple exercises in NetsBlox helps again to level the playing field. And once students are comfortable processing lists of data, we begin to explore natural language processing concepts in NetsBlox. A good example is Sentimental Writer, which I'll turn to Brian in a moment to demonstrate. This is a project that Brian designed to show the application and limitations of sentiment analysis while working with 18th and 19th century texts. And NetsBlox extends the snap programming language here by integrating a remote procedure calls, as you know, to connect with web-based applications. And in this particular case, the Sentimental Writer connects with the Parallel Dots API to carry out sentiment analysis. But Brian, why don't I turn it over to you to just talk about how it works in practice?
Sure. So basically, as Cliff mentioned, we're working with these students from different backgrounds, some coming from the humanities and some with a prior programming experience. So one of the things that we've been trying to do is use NetsBlox to introduce programming with the intentions of eventually being able to analyze these 3.4 million documents from 1700s anyway. So we start with activities that are still designed to be kind of themed, I guess, accordingly. So in other words, this is one of the activities that we've started with for students who might not have prior programming experience, giving this max block to students automatically. But basically, students are able to use the Parallel Dots service in NetsBlox to perform sentiment analysis. And this is a pretty simple example. You can see this is the entirety of the code that's required, but it does require them to start thinking a little bit about the flow of this interactive typewriter, as well as starting to think about some of these like the lists and actually two-dimensional lists or tables, as we can see here. This specific, like the end result in this case, is just this semi-intelligent typewriter that when you type something, performs sentiment analysis on it using the Parallel Dots API. And depending upon the results, it'll color code the text accordingly. So this sentence is not very interesting. Oh, what? Apparently it's more interesting than I thought. Okay, this sentence is fine. Dang it. Okay, so I was trying to, that one was just positive enough, I guess, to hop over. I guess that, anyway, there we go. Now, so you can see that when I type with this typewriter, we can start seeing that the text is color coded accordingly. Now, the thing that's interesting here is there is the, it does serve as an introduction to programming for some of these students who don't have any prior programming experience, or on a task that's somewhat familiar, but also opens up discussions about how exactly this model is able to determine the sentiment, and what the weaknesses might be, what happens as the text gets further and further from the text it was trained on, and these types of conceptual questions in a way where the end result is really this project that lets them probe the model and test it and try different things. So for example, we've had students in the past who have just taken sentences out of these old periodicals and entered them here and tried to see what sorts of results they get and reason about whether or not those results match what was expected, and why or why not. So I can pass it back to Cliff now, if you wanted to continue on.
Okay,
Or I
thanks a
can
lot.
hop into the next demo, whatever you're.
I got a short intro, and then why don't we do that? So this is just to bridge these demos. I'll just mention that we have a slightly more complex example in NetsBlox, which involves the application of natural language annotation pipelines to our data. So in this case, Brian has built a connection with Stanford's core NLP library, which provides a set of annotators to analyze and transform data. And using the call RPC block in NetsBlox along with map, keep, and combine, we teach students how to link these annotators into pipelines to achieve practical ends. So one of the examples, I'm not sure if this is the one that you're going to show, but we've got multiple ones, is a true case annotator in core NLP. In this case, the annotator will take a set of tokens, and they may all be in capitals. For example, in our data set, all the titles are rendered all in capital letters, and turn it back into what it thinks is the true case. And in this case, we were looking for a kind of title case. So in our classroom exercise, we're able to build a pipeline that converts the titles of the articles that they're rendered in capital case back into title case. And this requires students to run a series of transformations over the data, loading the source articles, extracting the titles of articles, tokenizing the words in the titles, finding their true case, and then concatenating them again. And again, we stick primarily to map, keep, and combine because those are the same tools that they'll need to use on Spark.
Yeah, exactly. So to jump into a short demo, before I get all the way into the demo, this is just a short demo of, I guess, core NLP. So basically they have just a website that you can use to try it out. You can type something like, I'm happy to be here, and say what sorts of annotations you want it to perform. And once you submit it, you can see that it does all sorts of intelligent things, like noticing that I is a personal pronoun and M is a present tense, a verb in the present tense. And it can detect all these other parts of speech as well as like lemmatization. So you can make sure everything's in a standard format, like it recognizes that this apostrophe M is actually a form of the verb be, etc. Now, this is cool and exciting and fun to look at and play with, but it's not really easy in this format to use as part of a bigger pipeline. So we do have the ability to integrate it within NetsBlox. So we could do the same thing here by annotating the I'm happy to be here text. And I can perform like lemmatization to figure out what the basically standard, or to get basically a standard form of the word. So if I run, if I call this RPC, we can see it gives us our result as a list of sentences. So I can just continue to kind of build this up. So we could see that when I look at the contents of each sentence, I get this kind of funny looking table. These funny looking tables often mean that it's actually a list of tables. So if we switch to a list view, we can see that it is in fact a list with a single sentence that has an index and tokens. So just to kind of quickly let us explore it, you could get the contents of the first sentence and get the tokens from that sentence. And now we'd be able to see things, again, that funny representation that we see before, which often means that it's actually a list of tables. And here we can see that we actually get the word I and the word and the apostrophe M. So all the data we saw before, we can see the part of speech tag, the lemmatized form of it, and so on and so forth. So the nice thing is that when we start working with this much data, it can become pretty natural, I think, to start introducing things like map and reduce, and things like that, where we'll maybe assign this to a list of tokens and then just focus on one at a time. So one of the tokens, and say maybe we want to get the part of speech tag for it. And then with the students, it seemed pretty natural there, like to introduce map, where we're kind of first, I guess, programming in the small, if you want to think of it that way, considering just a single one, and then just convert this into doing it for everything. Now we have the part of speech tags for everything. So you can see personal pronoun, you can see a verb in the present tense, and so on and so forth. And of course, we could lemmatize it as well. So this is just a quick little example of the of introducing some of these natural language processing tools into this environment. But as Cliff also mentioned, the motivation for introducing this was really so that it could be part of a broader pipeline. So when students were working still within NetsBlox to explore some of these British periodicals, we'd store like a number of periodicals as a cloud variable that they had access to, and then connect to BaseX so they can actually request that document from the database. And once they did, we were giving them, like, they'd see a document in this form. And I realized that I am going very quickly, just in the sake of time, to kind of give you a expedited tour, if you want to think of it that way. But if there are any questions, of course, feel free to hop in. But essentially, another benefit of starting with NetsBlox is really that they can start to get more familiar with the data itself. So it's pretty easy to represent the data we are working with as a table, and give them custom blocks that only give you the keys that are available, so you don't even have to worry about typos. So that looking at a single document, they can get the publication date in like an alphanumeric form, or they could just get the whole text. Once they're doing things like fetching the whole text, then we were able to take this to some simple analytics, where we first fetch the data, or fetch some document or documents of interest, and then start using a lot of map and combine, in particular, to do things like, and of course core NLP, to do things like come up with a standard representation for each word, and then count like the word frequencies through a document. So then you could see whether it was maybe a law was coming up more in the middle, and maybe that's where you should really focus your reading, or towards the end. And then kind of continuing along with the idea of sentimental writer, students could then extend this even further, and we did this in class as well, where they could start combining these different concepts that they learned in the introductory exercise and these later ones, to start looking at some of the text of these periodicals and the sentiment through segments or partitions of the text. All right.
All right. Thanks, Brian. It is a whirlwind tour, and we'll we'll see if we have time for questions. But just to sort of wrap up, all these exercises were intended to make working with PySpark's functions of map, filter, and reduce more intuitive, and to allow us to introduce concepts in Spark by drawing analogies, for example, between the structure of Spark's resilient distributed data sets and lists of lists, or as you saw there in NetsBlox. And I think that students' familiarity with analogous concepts in NetsBlox seemed to lessen their cognitive load. So it allowed us to focus on more important concepts in Spark, like lazy evaluation and so forth. Furthermore, the familiarity with the data that they gained while working with NetsBlox enabled them to keep a focus on Spark's data abstractions rather than simultaneously trying to understand both syntax and abstraction at the same time. Of course, syntax remained a problem for those without prior exposure to Python. And as we introduce new concepts, we would step back into NetsBlox, that's the back again, to demonstrate what that concept would look like when built with blocks. And I think it was that iterative approach to NetsBlox that kept students focused on the semantics of our application, even as we expressed those ideas in an unfamiliar syntax. So just to wind up, as we plan for future cohorts of the fellowship, some ambitious questions arise about whether we could make Spark even more accessible to beginners. For example, would it be possible to connect Spark directly with NetsBlox? In theory, we could create an RPC to Spark using something like Apache Libby, which provides a REST-based interface to Spark. But I think a lot depends on the advisability and how far we want to push the idea of CS plus X or X plus CS. That is to say, the combination of computer science with a subject discipline outside of computer science, the so-called X. How packaged should we make the environment? And is it possible to make the experience too prepackaged? That is to give them an artificial sense of simplicity about what is inherently a complex tool. Those are the big questions that we're thinking about, and thank you for thinking about them with us. And if we have any time, we'd love to answer your questions.